All right, let's look at some homework problems from 7.2b. This is finding volume by the washer method. Now, some of these problems are mixed together, so we always have to look at the shader region, uh, look at the shader region in relation to the axis of revolution, and see if there's any gaps or holes. If there are no gaps, then we stick with this method, but only if there's a hole or a gap uh, between the axis and the shader region, then we have to apply the washer method. Okay, meaning that we have to subtract out the hole um, uh, for our object. So number 11, we have our uh, curves and lines that's going to create our shaded region. Y equals square root of x, that's this curve here. Y equals 0, that's the x-axis. X equals 4, okay, that's this vertical line here. So we have the shaded region here, revolving this about the x-axis. Okay, so here in red, dotted line indicates the axis of revolution. We're going to revolve this object around this line. Okay, so look at the shaded region. Look at this in relation to the axis. Notice that this shaded region is right up against this axis. There's no gap, there's no hole, so there's no need for washer method. We only need to do this method. So this method, we start on the axis, we draw to our graph or curve, and there's only need for one radius. So we do top minus bottom. Top of the graph is square root of x. Bottom of the graph is at 0, so square root of x minus 0 is simply square root of x. Everything is in terms of x because we're dealing in terms of top minus bottom. And our bounds, okay, the furthest left the graph is going to go is at 0. The furthest right the graph will be is at 4. So we simply plug into our formula. Volume is equal to pi from 0 to 4 of big R squared. So big R squared, this combines just to be x, and we go through power rule, we get x squared over 2. Plug in the upper and lower bound, we get 16 over 2. Don't forget the pi, we get 8 pi cubic units. Okay. Let's look at part B. We're going to take the same shaded region, okay, from part A, but now we're going to revolve the shaded region about the y-axis. Okay, so we're revolving this about the y-axis. Notice that, okay, look at now the shaded region in relation to this axis. You see that there is a gap, and because of the gap, this tells us that we have to use washer method. So we need to remember, always draw your radius from the center. This is the center of this object. Okay, we're going to start on the axis. We're going to draw to the further curve function or graph. In this case, it is the line x equals 4. Okay. Again, start on the axis. We're going to draw to the inner curve. In this case, will be the x equals y squared. And we determined that it's x equals y squared because we are rewriting our equation in terms of x equals. So initially, the equation was y equals root x, but then if we solve for x, we get x equals y squared. So this curve is now x equals y squared. Okay. Now we look at the, we determine big R and little r. The right endpoint is at x equals 4. Okay. The left endpoint is at 0. So we get 4 minus 0. That will represent big R. Okay. Little r, we look at the small radius, and we look at the right endpoint, which is at y squared. Then we look at the left endpoint, which is at 0. So we get y squared minus 0, and that represents little r. So our volume is simply pi big R squared minus little r squared. There's something that we also need to look for is our bounds. Okay? Our bounds is our lowest y value to our highest y value. So the lowest y value is 0 because this is y equals 0. This is the x-axis. Now the highest y value is not 4 because 4 is the x value. So if we want to find the highest y value, we will have to plug 4 into this graph so that we can find this ordered pair. Once we find this ordered pair, then we see that visually this is the highest y value on the graph, and we can simply identify that to be our bound. So plug 4 in for x, and if we solve for y, we're going to get y squared equals 4, so simply y must be equal to 2. So then we have y squared minus 0 being the small radius, okay, and our bounds being from 0 to 2, so big R squared minus little r squared gives us 16 minus y to the 4th. Okay, go through power rule, we get 16y minus y to the 5th over 5, and then plug in our upper and lower bound, we get 32 minus 32 over 5, and we get 128 over 5, and we have include that pi cubic units. Okay, part C, again, same shaded region. Now we're revolving this about the line x equals 4. Okay, and if you compare the shaded region with this line x equals 4, you see that the shaded region is right up against this axis. So there's no gap, there's no hole, meaning that we're going to only need the disk method. So we start on the axis of revolution, we draw to the curve, and this is the only radius that we need. But because this is a horizontal rectangle, we have to go through right minus left formula, meaning everything will be in terms of y. So we already determined from part B that this equation is x equals y squared. So we start on the right endpoint of the rectangle of the radius, so that's 4. So 4 minus, now the left endpoint is at y squared, so we get 4 minus y squared. And again, everything's in terms of y. We determined from part B that our lower bound is 0, our upper bound is at y equals 2. So we plug into our formula, pi big R squared. No need for little r, no need for washer method, there's no hole to subtract out. So we can expand this out, go through power rule, or plug in your calculator, and you'll get 256 over 15 pi cubic units. All right, part D, we're now revolving about the line x equals 6, the same shaded region. Now, if you look at 6 in relation to the shaded region, you see there's a gap, a hole. So that means we need to find big R and little r. So starting on the axis, we're going to draw to the further curve. That'll represent big R. And then we're going to start on the axis again, and we're going to draw to the inner curve, or the inner line, the inner graph, and that is the this boundary here, x equals 4. This represents little r. Okay. Again, your big R is always going to be longer in length than your little r. Okay. When we put them next to each other, we can compare their lengths. And big R first, we're going to start on, look at the right endpoint of your big R of your radius, and this is right at 6, so that represents the right endpoint, minus the left, so the left endpoint of your rectangle is at of your radius is at y squared, so 6 minus y squared represents big R of y. Okay, little r, okay, we start on the right endpoint, we see that it is right at 6, so 6 minus, now look at the left endpoint of your radius, this is at 4, so 6 minus 4 is equal to 2. Okay. Again, the bounds are from 0 to 2, just like part B and C, because we're looking at the lowest y value and the highest y value. Everything has to be in terms of y. Big R squared minus little r squared. Plug this in your calculator, or you can expand and go through power rule. Either way, you'll get 192 over 5 pi cubic units.